I've worked for 20 years in different research labs. And coming from South Africa, where I didn't have a technical background, in fact, I didn't have a design background, I've sort of learned that you can more or less bullshit your way into anybody's backyard if you want to. And by asking really, really stupid questions, you can produce quite interesting results. And effectively, that's what myself and my partner have done ever since arriving in England. And what is significant about this is the piece of technology that enabled human beings to survive the Ice Age. Right? It's a needle made out of bone. And what I think is really significant about this image is it design or is it technology? And one of my sort of bugbears has been that I think that design has stopped asking very difficult questions, and particularly of technology. We live on a planet, to state the obvious, that is completely littered with the effects of sort of technology that has just rampaged forward, and without a lot of consideration for why it's made or how it's improving things. Do we need to make a new one of whatever we're making every single year just for the hell of it, just because we have to, because we can't stop the machine? So in my the activity that I've been involved in for the last 7-8 years, we create what we call design provocations. We try to materialize lifestyle scenarios, they're called. They often touch on taboo subjects. We try to understand what very, very sort of low frequency, weak signals, how these things are going to manifest themselves, which of them are going to manifest themselves as mainstream trends later down the line. And so we cluster these things and we choose topics. We work with no brief. We assemble a group of people around a table that are drawn from a variety of different backgrounds. We're not looking for skills. We're looking for minds that can apply themselves in a conversation. We're looking for the reaction of a fashion designer to a physicist in a discussion about antennas, and that's an example I'll come back to later on the line. We're looking for people that are not pigeonholed and who don't have tunnel vision and who are not presupposing the result before they start. And that selection process is probably the only really skilled piece of work that I do. That in assembling a group of people where we can change, we can take a methodological tension and turn it into a creative tension, that effectively has been the key to this. So, as I mentioned, we don't start with a brief. We define a territory. The group starts to do echo soundings in that space. Depending on what the nature of the subject is, it's completely free. And as stuff goes along, so we either blow life into it or we kill it off. We couple things up. We think this is interesting, that's interesting. And it's only right at the end of this process that when we're going to publish a provocation, often these are movies that we put out on YouTube, or we materialize a particular scenario that gets exhibited. It's only at that stage that we will create a brief for that specific little piece of work. As I mentioned, these are often collaborations with artists. We feel that art is an instrument of innovation that is completely undervalued. Artists and scientists get along extremely well, unlike designers and engineers. So I was going to run through just a few examples, just in mainly just to convince you that we're not pigeonholed, that we don't stick to our comfort zone, that we will wander into other people's backyards or even sort of enter via the cat flap. So this was we were interested in how people felt about electronics in the body. I'm going to whiz through a few examples because I'd really like to talk to you about some of the work that we're doing currently, which has relevance to you all in that a lot of it has been based in Cape Town. So we were interested in how people felt about electronics in the body. It seemed to us inevitable that ultimately we would have a lot of subcutaneous technology and swallowable technology and all of the rest of it. If we had chosen to look at medical implants or swallowable cameras or anything like that, people would respond to the brand, they would respond to the product ranges that the companies we work for produce. There would be it would be very, very difficult to get a discussion and a debate that wasn't clouded by those issues. So we worked with a tattoo artist who's very well known in Amsterdam. He's done many famous rock stars. And we worked on this concept of an electronic tattoo. And I should point out that nothing we show, I mean, electronic tattoos don't exist in the form that we are showing them, is addressable, biocompatible, ink, feasible at some point in time? Absolutely. There's no science fiction. There's no flying from here to Durban with sneakers that can elevate you. They are probable, right? Even although they don't necessarily exist. This is work that we've done with James Auger, and I'm not even going to mention anything about this because you've got the world champion of smell exploration talking later on in CSAL. And but I show the image because it's pushing those taboos, and we're looking for taboo subjects. This is work on microbial fuel cell powered robots. It's a movie that you'll see shortly on YouTube, hopefully, if you're interested, which is all about, in a sense, the kind of the future of garment manufacture. We wanting to provoke a discussion amongst kids as to how it is that you can buy a garment in Europe, in the high street, for 10 euros and not think about what sorts of forces and pressures were brought to bear to make it possible for you to do that, right? So in a sense, it takes the history of automation, this slow progression of automation into the textile world and projects it into the future. This is collaborations that we've done with Juan Maria Atzak, who's a 3 Michelin star chef in San Sebastian, who's been in the top 10 San Pellegrino list all his life. 4th generation restaurant. We're looking at a variety of different aspects of food, including the subject of multisensorial gastronomy, or how you apply the science of sensorial plasticity to enhancing the gastronomic experience. What we take from these, this is not just, as much as we have a massive amount of fun doing this. Can you imagine eating your way around northern Spain doing the research for this? The discussion and the debate that we stimulate, and what we call contextual insights. We don't believe that you can get consumer insights in an horizon that distant, but in understanding that context, we feed that back into nearer term scenarios. Anyway, I think that's enough of kind of methodology. Or maybe I will use this example. We have an annual technology exhibition in our company where 10,000 people from this very large global corporation, come and have a look at circuit boards on tables, new and emerging cutting edge technology. And I find that very, very stimulating, but the application of it is completely invisible. It's very hard often to see what the implication of that is, where it's going. And more importantly, you don't see what it's not doing, or alternative ways of doing those sorts of things. So we decided to work with some fashion designers. We'd been working with Nike on biometric sensing in the build-up to the Sydney Olympics, and we'd developed a myriad of different sort of techniques for doing non-invasive biometric sensing, heart rate, galvanic skin response, blood oximetry, and so on. But all attempting to get an athlete, a 100-meter athlete, to improve a performance by a millisecond. And it occurred to us that if you could put the person in the zone, one of the problems was anxiety, something that I can well identify with, looking at all of the whites of your eyes. If you could get that athlete to relax and to concentrate at the start of that process, that was money in the bank. It would be directly translated into performance. And you could see how using a combination of different biometric indicators that you could start to extract emotional data. So, something we felt very, very strongly about is it's taken 25 years for a 3D accelerometer to be included in the phone that's in your pocket. It has the processing power to take a spaceship to Venus. And yet it has the sensitivity of a frozen chicken. It can tell you absolutely bugger all about, it knows whether it's horizontal or vertical now, but it can't tell you whether you are. It doesn't know whether you're sitting, standing, having dinner, in a traffic jam, or anything. And we find that really, really irritating, that all of this technology presents itself to us in a way that demands us to learn how to use it. Right? Why is it that we don't have an interface that everything else adapts to? Why is it that we don't communicate? All of this indirect communication that is going on now, the 90% of what I'm communicating is not verbal. It's probably obvious. Why are we not using that in the way that we speak to machines? So we presented this. This is a dress that blushes. It picks up very, very simple emotional data and it transforms. And it had the most unbelievable effect. We did it sort of more or less because we were in a rush and we felt like we'd spent 10 years doing wearable electronics and liked doing fashion. And it had the most unbelievable effect. It just will not die. It sort of it struck a nerve about emotion. So that's an example of a probe, something we materialize, we put out, we have a debate, discussion. We can't be proved right or wrong because it's all speculative, and we feed the information back. Coming to what I'd said I wanted to talk about, which relating more to this urban context. I think I'm stating the obvious. We all know that in the next 25, 30 years, our population grows by 40%, somewhere between 9 and 10 billion people. And what really horrifies us is that there is a big debate about how much our primary resource consumption increases. Some people say that our electricity consumption goes up 300% as 70% of the world becomes urbanized. And what's even more horrifying is that to fuel that, and I'm not even talking about water and food and many of the other problems, sanitation, that come with this massive explosion. The fact that we do not scale from 10 to 20 million in a city very, very easily is just to fuel that electricity increase. We're talking about 6,000 new nuclear power stations, right? And which I find absolutely horrifying when, we 25 years after Chernobyl, exactly the same things happen in Fukushima. So 70% of us are urbanized, and most of that urbanization is coastal, the effect that it has on water. So what we started to look at was how we wanted to try to understand the sort of cycle of our life in very, very simplistic terms, and to try to find the interconnects between these services. Our cities draw very, very heavily on a power generation plant, and I apologize to all those of you involved in power generation. But in fact, you're all involved in power generation. You just don't realize it yet. All of that, that is very much an activity that is seen in isolation. It's not connected to sanitation. It's not connected to food. It's not connected to many of the other services that we rely on. They are polluting in and of themselves. They're very, very inefficient as individual systems. So we wanted to take the home as an ecosystem and to try to sort of interrogate a lot of the processes that we take for granted and think about alternatives. And we were particularly interested in trying to create a home that didn't run on electricity, or that was off the grid, and that harnessed the sort of end-to-end efficiencies within that system. And so we created this scenario. And we'd been working with an NGO in India called the Sulabh Foundation, who are absolutely unbelievably world-leading in this field. And we designed a squatting toilet, mainly because the incidence of colorectal cancer is so much lower with squatters. And in Western cultures, we seem absolutely determined to put ourselves out of business. So, And from the toilet, which separates effluent and human solids, we located a methane digester in the kitchen, and we did that for very much to provoke a discussion about the issue of shit. And in fact, we did a separate artwork with Harm Rensink, who made a tea set for an exhibition in London, which was made out of shit, and we had to import 11 kilograms of petrified shit from India, from the Sulabh Foundation, and it became very, very interesting because it brought Europe to a standstill. You know, the idea, even although it was benign, or so we thought at the time, and anyway, that's a different story. So we have a methane digester, and you're basically cooking using human gas, which, interestingly enough, is non-odorous. Sulabh have been doing this for a long time. In all of these provocations, we amplify things. This, for exhibition purposes, you don't need a tank showing you whether you got gas at the top of it. It's amplified to demonstrate how these things work. But basically, vegetable trimmings and human solids are brought into the kitchen. Gas is taken off it. You know, many people in the company that I worked for were sort of asking me whether I understood the business model, that we made LEDs and that using gas light running on human fart wasn't necessarily the way to go. Sort of decomposing human waste generates a lot of heat, so we heat hot water pipes which come over to a thing called the larder, which has an evaporative cooler in the middle of it, which basically cools food. And the scientists in the group, in the audience here, I'm sure, are saying, yeah, but that's not going to work in the tropics, or it's, equatorial conditions are not going to allow you to evaporatively cool. We know, okay? And we know that you can't run a household on 4 people's waste, no matter how much they eat. So, but in our collaboration with the bioengineering department at Technical University, which was an absolutely incredible sort of discovery for us, because it gives this new language, this new vocabulary, this new set of tools to design with, and I think it's the challenge for design in general. What was phenomenal working with scientists who could design bugs and who could take these things apart and put them back together again safely, is that they didn't see that as a problem at all, that these are just efficiencies in a sense. They thought it was completely feasible. In fact, CNN threw an Oxford Don at this concept as well, and he also gave it a clean bill of health, which really surprised us. The cell phone battery was this big 20 years ago, and now it's something that fits in your pocket. We need to work at that. We need to make these things efficient so that they can run and they don't time out when people go away for the weekend. From that methane digester, we take gas, and this was the part that we thought was really, really elegant. And we worked with an artist, a Hungarian artist called Ákos Molloy, and then later, as I said, with the people at the TUE, on basically developing bioluminescent bacteria that would eat methane and eat the sludge that came out the bottom of the methane digester. So this is something we call the BioLite. Those contain fluorescent proteins, because in trying to get 40 liters of E. coli from London to Salon de Mobili in Milan, April 2 years ago, it proved to be somewhat of a problem. And so we switched to fluorescent proteins, and in fact, we're now in the process of combining the two. We're getting bacteria to agitate the proteins. But the idea and we know that you're not going to do your homework to this level of light, but it's asking the question about how we generate power and where the stuff comes from. This was a beehive. We'd been looking at the issue of slow health, in a sense, in how health is diagnosed. And again, there are people that are far more qualified to talk about these things who are still coming, but we're struck by the fact that we sanitize every single surface that we come into contact with. We know that we're basically harming our immune systems and in sort of disabling the abilities that we have as a natural species. And that struck us as really unusual. And they'd published this information about NDM1, this latest superbug that had come out of a plastic surgery clinic in New Delhi, and which struck us as unbelievable, that the most sanitized, the cleanest places on Earth were the places where these bugs were developing, And we'd read a little article about the effect of honey in combating the superbugs. Now, as you all know, bee populations are in decline. There are many, many different theories as to whether it's mites, whether it's the short microwave radiation that is killing them, but 40% of everything green on the planet is pollinated by bees. No bees, none of us are sitting here next year. So, and there are these absolutely unnatural processes. They take 100,000 trucks full of bees for 1 week in California just to pollinate the almond harvest, the almond, whatever happens before harvest. So we were, and an interesting thing about urban honey, counterintuitively, is that it's much nicer than rural honey because of the biodiversity. So we wanted to make an urban beehive, and a lot of this particular probe was designed to teach kids. It was designed to teach kids that honey comes from bees, and you could see how it was made rather than come out of a squeezy tube in the supermarket. So it sits on, and it has there's a hole drilled in the glass. Bees come through the outside, and they like darkness. So the bottom of this thing is dark, and the top of it is a particular frequency of yellow that they particularly like, we're told. And it's designed. The interesting thing is that you print the leaves. You just print the pattern, and they follow the pattern and build the comb. Maybe that's a human intervention just to make ourselves feel better. Maybe they would have done that anyway. But so I threw this slide in because I'd been having discussions with people in Cape Town about some of what was going on with craft and so on. And we intentionally didn't want to use anything mass manufactured in this. None of the materials are plastic. They all involve sort of artisanal skill, much of which is sort of is disappearing, as you know. And the forms and even a lot of the function of the different objects in this were very much determined by this unbelievable skill of people blowing glass and working metal. It absolutely amazed us that they are these unsung heroes behind the scenes, that in industries or in crafts that are in serious decline. Those skills are disappearing because we don't use them, because we're much keener to stamp out things, as Porky was saying in his talk, and mass manufacture. So I hope very much that the Cape Town initiative carries on. Anyway, moving beyond this, in 2005, an absolutely inspirational American scientist did a TED talk on mycelium, and which, I'd encourage you all to have a look at, a guy called Stammet. And there was a moment in it where they convert diesel oil using mycelium, which is, as you know, is a byproduct of mushroom, or component of mushroom. And so we started to experiment with this. That seemed to us to be absolutely magical, that you could take a natural material, something that occurs in old forests, different to cultivated wood plantation put up there saying, yeah, we replant the mountain. completely different, right? Because all of that diversity disappears when you chop down these old woods. And what happens is you mix this stuff with, you take all of this kind of toxic material and you mix it with mycelium, and this magic happens. It sprouts mushrooms. And we assumed that those mushrooms would be absolutely radioactive, that you wouldn't be able to go anywhere near those mushrooms. And our kind of early toxicology test actually showed that that's not true, that there's this miraculous natural thing that is taking place. Although I didn't say to you, go and eat mushrooms that have been grown on diesel oil, right? So we wanted to, again, make something for kids to in the research, we were really horrified to find that all of these recycling in Europe anyway, I don't know what it's like over here, but every plastic container's got this thing about this little recycling badge on it. And when you really start to look at it, you see that there are a whole bunch of them. They're not consistent. And when you research what happens to this stuff, in fact, very little of it actually gets recycled. It simply means that it can be recycled, but it's a pain in the ass because it's really time-consuming and expensive. Yogurt pots in particular, those cute little square-ish, hard plastic yogurt pots don't get recycled. Why the hell are we putting them in hard plastic? What is the matter with us? If it's going into the environment, why are we not using soft plastic? Why is it that we can't use the plastic of a water bottle? Not that we should be using those. So we made this, which was a contraption to teach kids, because there's no technology in this. This is absolutely unbelievably simple. You mix it and you leave it. That's it. But we wanted to create something that was a little bit mysterious and a little bit that showed the sort of the time involved, and to teach a ritual, to get kids to crunch up their yogurt pots and the sort of polystyrene-based plastic stuff, and to put it into this device and watch it sprout, watch it become something magical. And the reason, and once again, we worked with this, when my first job in the UK, I worked for the chief scientist of Thorn EMI, and absolutely, one of the three gurus of my life. And he saw the value of design. His team was staffed with designers, myself and Jack, and as opposed to nuclear physicists. He collected little pocket watches, antique pocket watches, and these represented a period of time when we were starting to move from a kind of faith-based system in developing timepieces at any rate to science. You could predict time using scientific principles. But even although it worked and you knew that it worked, they still hedged their bets and they engraved these little gargoyles and things to chase away the evil spirits, just in case they'd got it wrong. I wanted to do just a couple of minutes on this, if I can. This is something we're looking at very much in response to what we'd been learning in the microbial home work that we'd been doing, and it's been heavily influenced by, Indaba 1010, Luyanda Mpalwa's houses, and many of the people that Cape Town has very generously put me in contact with about microcredit and a variety of other things happening down here. I think that Cape Town, to a certain extent, is a sort of a microcosm. It's the kind of early warning system for the world of what is coming. And, a theme of ours had been livable cities. Once again, we navel-gazed about different things that we could look at. We went and looked at eco-cities and pop-up cities and the sort of, transformation of the hutong into the copy-paste housing in Asia and so on. But you saw Alfredo's absolutely brilliant talk 2 days ago. Someone from Urban Think Tank had been a consultant on the project, and they'd showed this image of Caracas, and it was the official map of Caracas, which had all these sort of nicely laid out neighborhoods and so on. And there were these big green spaces. There were these parks all over the place. And then they show you the satellite map, and those parks are slums. They are the most densely populated parts of Caracas. And for us, it struck us immediately that this was the contradiction, that there's this, we're in denial about the fact that 70% of urbanization that we're talking about, it's not Toronto and Melbourne and the shiny, happy places that we think of as the sort of the most livable places on earth, as in the Economist's list. You also find Osaka, 25,000 people, and this is pre-Fukushima, right? This is pre kind of the homelessness that resulted as a result of the earthquake, The phenomenon with Arab Spring, you've got this massive influx of people into Europe, which is not, and this is not the new phenomenon. This is simply making it more visible. You had in Sangat and Calais, you've had people living in the forests and in the bushes for a very long time, ever since pulling down a refugee camp that was put up there. And the contradiction within our political system, where one European country says, well, where are these people headed? And they say, well, they want to go to London. They say, let them through. No problem. It's kind of, so we see this as an inevitable trend. And there are a lot of very, very common characteristics to how these communities are formed, and in particular how they look at housing, how they address it. So as Alfredo pointed out, it's extremely difficult to retrofit a slum, and I'm sure there are people in this audience that know a lot about that. You can't go and, without demolishing thousands of people's houses, you can't go and refit sanitation later down the line, or water, or lighting, or many of these sorts of things. And the kind of lawlessness of the internet, you see the shift from formal, regulated, this world where, of parking meters, where mail is delivered and so on, shifting to informal systems, whether you're looking at healthcare systems in Europe, or you're looking at the nature of the courts in the UK. But I don't have time to go into that. So we started to look at what was happening in Gauteng and in Cape Town. I'm sure you'll recognize a lot of those places. And we came up with what we called an urban dignity charter. What are the 10 things that everybody on the planet should have in terms of housing, right? Including, and in fact, we realized there was an 11th that we had been underestimating, and that's the aesthetic, that people have a right to live in beautiful environments, that, nature is beautiful. That's where we were intended. What is the matter with, and in applying a lot of those natural processes, how we could design a space based on nature, on gravitation, on heat rising, on things filtering through different materials. And this is work in progress. We're along the way. As I mentioned, we create an optimal solution, and then we try to deconstruct it to look at how you could create self-help based on the individual components of it. So the initial idea is very much based on sort of biomimicry, that you would have all 10 of those needs, in a sense, provided by, or catered for by coupling in an end-to-end system the output from one system into the input to another. So it's made up of tiles and bricks, which each one of which has a sort of a variety of different functions. Somewhat masculine design, I accept, but that's mainly because, you know, we're in a sense the sort of thermal movement within it. It's going to be a very, very breezy 15 square meter place to live in, that's for sure. But it utilizes the natural processes extremely well. From that optimal thing, we've deconstructed that, and we've tried to figure out how could you take the optimum or the most appropriate sort of water filtration system or water capture system or methane digester and apply it to different situations. You know, how would it work in Kibera? How would it work in Diepsloot? How would it work in Hout Bay? And how you could try to stimulate. In speaking to people in Cape Town, we were really struck by the fact that an enormously high percentage of microcredit goes into making burglar bars. Why? Because it's something that you don't need a lot of equipment and skill to make, and there's certainly a huge need for burglar bars. And how could you basically stimulate how you could encourage self-help and try to change a situation that was completely absent of those services by encouraging people to make the individual components locally. That's it.